and we want to talk about solving equations by factoring. And these are called quadratic equations. So the first thing we want to do when we solve quadratic equations is identify what's called the zero product principle. Now, you don't want to do this in your homework. You don't want to do the zero product principle there. You want to put a lot of effort out. But what it says, the zero product principle, if A times B equals 0, then A must be 0 or B must be 0. All right, and let's go to some more examples with that here. Notice I've even put the extended zero product principle down. I did the whole alphabet. If A times B times C times D, E, F, G, H, I, J, K, L, M, P, all the way to X, Y, Z, if I multiply the whole alphabet and set it equal to 0, and any one letter of the alphabet equals 0, then what? The whole thing's 0. It's that multiplication property of 0 we talked about. So some examples in algebra with this. Here we've got x plus 3 times x minus 5 equals 0, and we want to solve this for x. So whatever number I put in for x that makes that 0 or that 0 makes the whole thing 0. That's what the zero product principle says. Now what number, if I put it in here for x, makes that 0? Well, if you're not sure, you can take that parentheses and set it equal to 0. X plus 3 equals 0. Or you can take the second parentheses, set it equal to 0, and solve for x. Now, most of you say, Young, I can look at that and tell what makes it 0, but if not, here's the, proven method. Now, to solve an addition equation, this is good review from previous things. We subtract from both sides, and we get x equals -3. So -3 would make that 0, and if one's 0, the zero product principle says it's all 0. Over here, to take out subtraction, we learned in the past to attack that with addition, or x would equal a +5. All right, so two answers to this right here, -3 or +5. Let's look at some others. Solving quadratic equations by factoring. Now here, I have 3 things multiplied together. 1, 2, 3 that equals 0. So whatever makes one 0, remember, makes them all 0. So what makes this y here 0? Well, when y equals 0. 0 makes him 0. And if he's 0, they're all 0. Or what makes this one 0 if I plug in a 2 for y? 2 minus 2 would be 0. Or how about this last answer here? What would make that parenthesis 0? A -7. So you can kind of look at some of these and you can go ahead and write out the answers. So that one would have 3 numbers for y that would make it 0. All right, now look at this one. Holy cow, Young, you're getting really crazy with these. All right, so we can go down here. Now notice there's just a plain old number in front of this next example with no variable in it. All right, now remember, this is 5 what with all these parentheses? Parentheses means multiply. It's 5 times that, times that, times that, times that. So if we don't like that 5 there, we can divide both sides of the equation by 5 and chop those out. Anything divided by itself is 1, and we gave it the yeah. Okay, now when I divide 0 by 5, doesn't matter, I still get 0. 0 doesn't care what you do to him. All right, so now I can get my 4 answers here. You can look at this first one and tell what makes that parenthesis 0 when x is 7. This one you may not be able to tell just by looking at it what x would be to make that 0. So you can come down here and take that whole parenthesis, set it equal to 0. All right, so to solve this for x, we have a little mini equation here from past lessons. Great review at this time. So first we want to isolate x by getting rid of the subtract 7. How? The BS is back. Add 7 to both sides. I know what some of the film guys are saying back there, the BS has never left, Young. You've been up there. All right, but anyway, you're going to have 2x equals 7. All right, now to take out 2 in front there, that's 2 times x. We're going to divide both sides by 2, and we're going to get x is 7/2. All right, so that's my second answer. Let me sneak it in over here. So 7 made that first one 0. 7/2 will make this one 0. And we could keep doing that. I'll do one more here. Let's take 5x plus 2 and set it equal to 0. This will help us work on our equations a little bit, good equational review. So to solve this mini equation for x, we want to get rid of the plus 2. How? By subtracting it And if you do it to one side of something equal, BS, both sides. And then that leaves us with 5x equals a negative 2. Those 2's go out. Divide both sides by 5. X is a negative 2/5. So I'm just stockpiling answers here for x. I've got 7, 7/2, negative 2/5. Now you guys ready for the shortcut here? The shortcut? Notice these answers, 7/2. And look at this up here. We've got positive 7/2 out of that. Look at this one. We ended up with a negative 2/5. Something about these answers and these numbers here and the signs, what we're doing is actually taking the opposite of the second number and putting it over the first number. So let me cheat and get this third one. And it's not cheating if you're smart, so you don't have to keep setting these things equal to 0 all the time. This answer would be 17/11. Now, if I take 17/11 and I put it in here for x, which I'm going to, what happens to 11 times 17/11 if I put that in for x? Well, the 11's chop out, leaving me with 17 minus 17, giving me 0. See, so there's a little cheater's rule, and I'm going to run through that with you to save you time, because you know what they say about time. Time is money. Yeah. All right, so shortcut. Here we go. You just get these things on this network, I tell you. Now look at all these nasty ones. If I took each one of these and set it equal to 0 and solve those mini equations, it'd take me forever. So let's do the cheater's way, and I want you to follow along here. So what answer would x be to get 0 here? Take the opposite of the second term's number divided by the first term's number. See, so here's the shortcut to solving. Take opposite of second term number, divide by first term number. So the opposite of that is a positive 1 over 4, 1/4. What would the next one be? The opposite of the plus 2, minus 2 over the first term's number, 3, minus 2/3. Y'all like that shortcut? How about the next one? The opposite of the negative 11, positive 11/5. And boy, as they get larger, this is a really nice little trick. The opposite of a plus 17, minus 17/6, and there are your 4 answers. How about that? What a time saver. See, so if you were to set them all equal to 0 and go through the equational things, you would get that, guaranteed. All right. Now look at this one. This is about as bad as they can possibly get, young. 1, 2, 3, 4, 5 things with variables multiplied to equal 0. Now 5 times x, 5x equals 0, what would x have to be? X would be 0. Okay, so that first answer, 0, would make the whole thing 0. And remember, if 1, 0, any one of them, the zero product principle says if you're multiplying, they're all 0. Excuse me. Next one. How about this one right here, the trick, minus 9 over 4, as golfers would say. And next one, positive 11 over 6. So that's a nice little shortcut rule. Now, it really even works with one like this. Y'all would say, I can look at that and tell it's negative 2, young, but you would say that would be negative 2 over what number's in front of x? 1. See, so it even works with one like that. Now, that just becomes plain old negative 2, so we usually don't write the 1 there. Yeah. And then the last one would be 2/13. All right, so in this case, we had 5 variables multiplied to equal 0, which yielded 5 answers that would make each one of these separate things parts 0. All right, so that's a nice little shortcut. Thought I'd show it to you. Now let's go to some equations here. All right, equations. So we're going to get into some like this, and I have a graphic on that too as well. Let's look at that real quick. They basically say the same thing, but solving quadratic equations by factoring. Now let me bring my hand up. I haven't had the hand here for a while. All right. Notice we're still in that good old ax squared plus bx plus c format, and a is still going to be greater than 0, which means it's going to be a positive number. All right. So the only difference in what we were doing and what we're doing now is we have the equal 0 right here. So I like to play with this stuff when the film guys let me there. Play with the hand. Now watch the hand disappear. Say bye. Whoop. Okay, bye-bye. He's out of here. All right, so let's go back to the example here. And notice this is not in this form. It's not equal to 0. So we're going to have to bring this negative 6 over here if we want to solve for x by doing what? Yes, adding 6 to both sides. So what that does is it gives us x squared plus 7x plus 6 equals our hero 0. All right. Now, can you look and just tell what numbers are going to make that 0? I can't. So that's where the factoring comes in we've talked about. And this is a factoring example, and there's a 1 in front of the x squared. So we can say 1 times 6 is 6. Factors of 6 to get me 7 in the middle will be 1 and 6. Signs would be plus and plus because remember the outside factors will always add to give you the middle. And we can hum a few bars of somewhere over the rainbow. So when we factor this trinomial, we'll get xx because there's a 1 there. Those are the nicest ones. Plus 1 plus 6 or plus 6 plus 1, it doesn't matter. And those would give you those rainbow numbers. All right, so now we're actually solving and figuring out what numbers x are here. So what makes this 0, what makes this 0 is my answer. So my two answers for x would be -1 or -6. And you can check these. I love equations. Like from the earlier lessons, you can take the number and plug it in here. It'll make perfect sense. Let's check one of these. They'll both check, but let's just take -1 being the easier one and to save time here, and we'll plug it in. So if I take -1 and plug it in for x, here's what I get. All right, -1 squared, order of operations, Aunt Sally would say do the exponent first, is -1 times -1, so this would be a +1 here, okay? 7 times -1 is a -7 or -7. Now, does that check? Does 1 minus 7 or plus -7 give me -6? Why, certainly. Yeah. Okay, and -6 would check as well. See, so the nice thing about equations, you can plug back in, check them, make sure they work. All right, let's try some more. Solve these equations for x, quadratic equations. Now, again, this is not equal to 0. So should I bring the 25 over here or the x squared over there with the 25? Well, we said we wanted to keep that x squared positive always, so I'm going to bring the 25 over here by subtracting it. So what that gives me is x squared minus 25 equals 0, and looky there, the old difference of two perfect squares. So when I factor that, I'll get x plus minus, the old conjugate pairs, 5, 5. So my two answers for x then would be, what makes the first parenthesis 0? A -5 or a +5. And the lazy person's way to write that sometimes, you'll see books write x equals plus or minus 5 for that answer. And if you think about it, it makes perfect sense. If I take a +5 and square it, boop, 25. If I take a -5 and plug it in there, square it, negative times negative, boop, both check. Nice, nice. All right, let me separate this a little bit here for the next example. And now here, I put the x's all on the right side of the equation. Are you panicking out there? Don't. Let's get it equal to 0. Now, since that's a nice positive number in front of that x squared, I'm going to move the 25 to the right by adding 25 to both sides. So that's going to leave me 0 equals x squared minus 10x plus 25. And look what we have here, Young. The first and last terms, perfect squares. The old friend, the trinomial square, it looks like. And when I factor it, I'm going to get two of the same things. In this case, xx minus minus, what? Yes, 5, 5. See, so I only get one answer to this one, surprisingly enough, because both of these came out to be the same thing, and when I FOIL it, it checks. So only one answer to this quadratic equation, x equals 5. Okay, so if I take 5, plug it in there for all the x's, it will make perfect sense. Okay. Let's do a few more with more complex things in them, because like we said, we just don't do the easy things, we do the more complicated things here. So now we're going to take this 2, we want to make sure it's equal to 0 and get it in that format by subtracting it from both sides. So we'll get 12y squared minus 5y minus 2 equals 0. So in order to solve this equation now, nothing in common to take out, so I'm going to go ahead and multiply the outside two terms. So if you can factor from previous lessons, boy, you're going to be real good at doing these and getting what values at y is. 12 times 2 is 24. What factors of 24 will give us 5 in the middle? I think most of us have been practicing this. We'll say, hey, 3 and 8. Since that's a negative 5, we will have to have a minus 8 plus 3. And those signs will have to be opposite to give me a minus 2 here on the end anyway. All right, so when I go to break this apart, there's some different things we can look at here. We can say 12y, except there's only one problem with that, is 12 times nothing gives me one of these rainbow numbers. So let me try again. 6y, 2y. Well, 6 times nothing gives me one of these, so I know it has to be 4y, 3y. All right, so we can force these, you know what. Rainbow numbers. So let's make our rainbows. 4 times what gives me a plus 3? Nothing. So it must be the minus 8. 4 times a minus 2 gives me the minus 8 on top, which means I'm going to get the plus 3 on the bottom if I know what number to put right there. And since these go together, 3 times what gives me a plus 3? Plus 1. All right, so now I've got it factored. Now I can use my shortcut, if I remember it, to go ahead and get the 2 answers for y, rather than taking that whole thing, setting it equal to 0, that whole thing. If you remember that nice shortcut, we'll come sneak over here and say y equals what 2 answers? Negative 1/4, the opposite, second over first, or positive 2 over 3. Positive 2 over 3. Now, if you struggle with fractions, boy, taking one of these and plugging it back up in here and making sure it checks, that would really help your fractions out too. So you'd actually have to square a negative 1/4 times 12. You probably have some chopping going on in there. Minus 5 times negative 4 would be plus 5/4, and I bet you it'll come out too. So maybe try that if you're a little weak there, but these will work. All right, now how about this creature here? I've just got 2 things equal. Now, do I want to bring the 3a to the right or the 6a squared to the left? I don't know. Well, I want that number in front of a squared to remain positive, so I'm going to bring the 3a over. How? By subtracting it from both sides. So what this will leave me now is 6a squared minus 3a equals our hero 0. All right. Now, what do we do here? We got a factor. Greatest common factor, 2 terms with some things in common. Take a 3 out, take an a out, and that will leave us with 2a minus 1 equals 0. Running out of paper here again, so I'll bring it up top. So what makes this one 0? 3 times what? 0. One answer for a would be 0. Or, using the shortcut here, the opposite of that second number, 1, over the first one, positive 1/2 will make that 0. So those will be your 2 answers. Now, let me boldly check one of these and show you what a daring person I am. I'm going to plug 0 back in for each one of these and show you how it works. 3 times 0, 0. 6 times 0 squared, 0. 0 checks. Now you try the 1/2.